Okay, today we're going to be looking at the indefinite integral. So far we've looked at the definite integral, sorry. So far we've looked at the indefinite integral. So the indefinite integrals, so we've got something like this. And it would be we would have this as our answer with the constant of integration. This is the indefinite integral. Now, if we integrate and set limits, specific limits to for the integral, say we set the limits between x equals 2 and x equals 4, such as we write it like this, we can work out the definite integral. And as we were about to see, when we work out the definite integral, we don't need to think about the constant of integration. So here, when you're finding out the definite integral, you write your limits like this. You write them to the right of the integral sign, or directly above and directly below. You don't write them on the left. So this would be, well, the integral of x cubed is what we've got up there, quarter x to the power 4. And we say we have plus c. Now we can put our limits here and here. Now we take the top number first. So we would have a quarter 4 to the power 4 plus c minus. Now later in the next video we're going to be looking at using the integral to find the area under a curve, and that will then explain why this is why we do a subtraction and an addition. But for now, so we've done the first one, 4 to the power 4. Now we do a quarter 2 to the power 4 plus c. If we work that out, as you can see, the c's will cancel out, and that would give us 60. So in general terms, we can think of the definite integral of f of x dx as equal to whatever that function is over a, with function, the value for b, and then the value with a. Now we have some general rules. The definite integral between b and a, if there's a constant f of x dx, like we did previously, we can take the constant out and then integrate the function f of x. If we're doing the definite integral of a function f of x plus or minus another function g of x, that's the same as saying this function f of x dx plus or minus the integral of the function g of x dx. So you can see that these rules are very similar to the rules that we've already previously looked at. This is an interesting one. So we find the integral of f of x dx within the limits a and b. That's the same as if we were to switch these around, minus b a f of x dx. And finally, if we have a function ab f of x dx, and we want to add it to the integral of the same function f of x dx, but within cb. That's the same as saying ac f of x dx. Now let's look at a few examples. First we're going to integrate 6x to the power 4 minus 1 over x squared dx. So this is the same as, so now we need to write this, and that'll be x to the minus 2 dx, which is, so we've got 6x to the squared minus x to the minus 2 dx. Now we will integrate that, so we use our square brackets. So that's going to be 2 plus 1 is 3, 6 over 3x cubed minus, and that's going to become positive because minus 1 is, I've done a 2 there, minus 2, and x. So yeah, it's going to be minus 2 plus 1, it's going to be minus 1, and that's minus 1 here, so it's going to become positive, and that'll be x to the minus 1. And we have our limits of integration here, and then we take our 2, so that's going to be 2 times 2 to the third power 3 plus 2 to the minus 1 minus 2 times 1 to the 3 plus 1 to the minus 1. Working all that out, we will get 13 and a half. Let's do another one. So we've got 3, 0, square root of 5, x plus 1 dx. So we're going to use the rule that we had in our previous lesson. So that's 0, 3, 5x plus 1 to the half dx, and we will get, so we take the 5 out from here and divide that there, and then we've got a half, plus 1 is 3 over 2, and then we've got 5x plus 1, 3 over 2, and so we will have 2 over 15 times 16 to 3 over 2 minus 2 over 15, 1, 3 over 2, and that will then, if we work all that out, we will get 8 2/5. And the final one we will do is minus 2, 1, 8 over 5 minus 2x to squared dx. Again, we need to rewrite this. So we'll have 8, 5 minus 2x minus 2 dx, and using what we learnt from the last lesson, we will integrate this 8 over minus 2 times minus 1, 5 minus 2x to the minus 1, and the limits are minus 2 and 1. Tidy this up to make it a wee bit easier, so we'd have 4 over 5 minus 2x. Then we substitute in for 1 first, so that'll be 4 over 3 minus 4 over 9, and that gives us 8/9. So I hope that helps.